Concave earthers are a funny bunch, aren't they? Happy that the world isn't flat, but instead curves inwards. Of course, concave earth is debunked thoroughly by simply looking up. The fact you don't see any of that earth curving upwards should be enough to tell you that it's not real. However, what if one concave earther came up with something that even I was surprised at? This is a concave earther debunking pi. Hello all and welcome along to another episode of Tinfoil Tuesday with me, SciManDan. Thank you very much for joining me. Before we begin today, a quick reminder that the new SciManDan Podcast episode is released tomorrow. This week we chatted with Fraser Kane from Universe Today, and last week we spoke with Matt Dillahunty from the Atheist Experiments. Just search for the SciManDan Podcast on your podcatcher of choice. Right, back to today's video, where a concave earther named DeRealM Concave Earth Apple thinks that he's debunked pi. Just so we're all on the same page here, pi is pretty much undebunkable. If we're talking about perfect circles, then pi will always be 3.14159, etc, etc. It's obtained by finding the ratio of the circumference of a circle to its diameter. If we're dealing with perfect circles, you simply cannot refute it. So I'm hearing all you ask, how does this particular concave earther do it? Well, the thing is, he didn't, and I think he even managed to confuse himself by the end of it. But before we start with that one, let's take a look at another one of his videos where apparently he's able to figure out the area of a circle without using pi.
Here we have a circle or a square. Both can be the same perimeter. We're going to go for example of 40 perimeter between a square and a circle. You know, a square's got 10 on both sides, then the area of that square will be 100. So with a circle, the square and the circle of the same area will have the same perimeter, etc, etc, etc.
No, having the same perimeter does not mean it's going to have the same area.
So if the circle is 40, and divided by 3.16, which is the square root of 10, 2776602. Let's just round in it off. Get that. That's your diameter. Divided by 2 is your radius. Times your radius by 5. Let's give you that. And times that by 3.1622776602. That's it. And that's how you get the area of a circle. Thank you very much. Sure.
What? Why is there a random 5 in there? This is just ridiculous. I feel like after his video, he should have had this.
It's false. No way. Not this time. We created it. Not this time. No, not this time. It's totally made up. Pure fiction.
Sorry guys, but I feel like he deserved the Jonathan Frakes beatdown for that one. Of course, in reality, if a circle had a circumference of 40, then the radius would be 6.37, and from that, we'd be able to calculate an area of 127.48. Anyway, he clearly showed us how to calculate the area of a circle incorrectly without using pi. Let's see how he goes about debunking pi, shall we? I warn you now, this is right up there with some of the most nonsensical things I've ever heard. That's your warning.
Hi everybody, I'm just showing another thing that is made sense, but it's actually nonsense.
Right! See, he's called it already.
How do you use straight measures? And we also have class 1, yeah, Halter 4s, yeah, this is the top banana, yeah, flexi, steel tape, the best that you're going to find. If not, you can find better.
The best you'll find. If not, you can find better. Makes perfect sense.
The US tolerance is worth equivalent to class 3 of UK tolerance. And then I don't know what happens for all the other places that don't use imperial or metric. And everyone says, yes, we've measured the world, we've measured the world, we've measured the world. Right, well, did they account for the curvature?
Nah, they just guessed.
Using a square law or where? No, they didn't, no. And we predicted, or we named the meter after a triangulation of measurements between Dunkirk and Barcelona, you get yourself a ruler, okay, and then you square up your tape measure. I tried to do it, but it blurred out too much. You measure from there to there, and don't mock me for having a blurred thing. That's why I'm not doing an experiment. You need to do it yourself.
Right, so you want us to measure a ruler with a tape measure. Okay.
And then what you need to do is you get the tape measure like this. It's hard to do with one hand, but I've got, okay. And then you get it tight, as calibrated to 20 centimeters, because these ones here don't have an end that is, you need to account for the nib, the thickness there, which is no good. So you need to get it flush, yeah, from start at the 4, for example, and you get to the end, and we'll calibrate, and then you calibrate, and then what you need to do is, how do you do it? Oh, you need to account for the curvature, okay? And when you do account for the curvature, you'll find that you get about 1 mil for every 30 centimeters. So that's...
Is he genuinely bending a ruler? I really am not sure what he's...
Works out to about, well, you do 1/3 and 1/3 of that, yeah, you're probably looking at about 3 1/3 millimeters. That's without tolerance. So if you want to talk to me about tolerance, tolerance is in a straight line. No one talks about tolerance using a curve. So even if something is slightly curved by that amount there, it's still going to, there's no tolerance accepted for that. So if all of you brain nuts out there can actually do what I've done and get yourself a class 1, yeah, which is 1.1 millimeter accepted and predicted variance, or whatever word they use, for 10 meters. So it's 1.1 millimeter accepted variance for 10 meters in a straight line.
So, what has that got to do with anything? We didn't invent a 40,000 kilometre long ruler and then bend it round the earth, did we?
Everything in the world is calibrated in a straight line. In a straight line. And then, when did we come out with the flexi rule? When did we come out with this? Did we take all this and remeasure the world? Of course we didn't. And then, yes, we say, well, the line and this, that, and the other. No, we just took some guy from late 1700s, word for it, few attempts or anything like that, and they came up with the distance, which was 1/1000th of the distance from Dunkirk to Barcelona.
There is a rich history of people figuring out the circumference of the earth. We didn't just take one man's word for it. And you can do it yourself as well.
So if anybody wants to tell me, oh, it's the speed of light. Yeah, it is. But the actual measure, yes, was all agreed on one thing. The basis on something that never happened. So if all of you could actually do me a favour and fact check this, then you'll actually find that 1 millimeter out per 30 centimeters, based on how extreme you want your curve to go. But if you're looking at a curve about that, you know what? It all depends on what shape you're talking about here. But if I were to do that, there's 1 millimeter already gone, yeah?
So because 1 millimeter is missing from your 30 centimeter ruler when curved, you think that a larger curve, say Earth's, would have a much greater amount missing. Am I right?
So if you've got variances, etc., use your Earth curve calculator and you might find, and no, it's not flat. No, it's not flat. No, it's not flat. It's just curves inwards like that and not outwards.
But wouldn't you still have millimeters missing if it was curved inward as well?
Either way, even if you were to say it's a ball, yeah, of course, I'll agree with that in many, many different ways. But some things I don't agree with. Well, it could be a ball, and maybe we've been all wrong all along, which 99.9% recurring would say that. But if we account for the curvature, per 30 centimeters, 1 millimeter. So if you put that out for 1 meter, that's 3.3 millimeters. For 10 meters, you can do the maths, yeah? Okay? You can do the maths. What's that? 1.33 centimeters for 10 meters, yeah? And then you times that by 40,000, yeah? Well, not 40,000, 4,000.
Wow, that was staggeringly wrong as well. There are 40 million meters in 40,000 kilometers. So you'd multiply your 10 meter value 4 million times, which would be 13.3 million centimetres or 133 kilometres.
And then, yeah, am I out? Oh, yeah, it's not a lot, yeah, I know. But when you start doing area and you incorporate pi, actually, the whole thing of this was to say, well, if pi is exact to straight, it's not exact to a curve, is it?
Wow. Let's hear that bit again.
Well, if pi is exact to straight, it's not exact to a curve, is it?
But pi isn't used with straight lines, is it? Unbelievable.
Well, I've got 13 mil for 10 metres, 1.3 centimetres for 100 metres, 13.3 centimetres for 1 kilometre, and then 5,320 centimetres.
He's even confused himself here. Amazing. That's not all though. 2 videos later, he apparently debunked pi again.
What's the difference between circumference and periphery? Doesn't that make pi? That's volume related only because it's the inner side, the inner circumference, and the outer is called periphery, which is the boundary.
That is utter nonsense.
Is 3.16 all the square root of 10, so it's not pi. No debate really.
Yeah, no debate. You've smashed this one out the park, buddy.
Should we just go look? Here's one. Not exactly outside, is it? Not 3D either.
What? It's as if he ends his video halfway through his point. Pi not debunked. And as I said before, you won't ever debunk it. Well, there we go. What an incredible attempt from DeRealM. Of course, completely wrong, but incredible nonetheless. Thank you all very much for watching today's Tinfoil Tuesday. I do appreciate it. I hope you enjoyed it. If you did, then please do like the video and subscribe as well if the feeling takes you. I have been SciManDan. Have yourselves a great week, and I'll see you all on Friday for the Patreon poll video winner. See you all then. Bye bye.